This is Oral Rehab Lecture 8, Part 3, continuing an overview of amplification. We resume at slide 18, continuing to talk about the components, the different individual parts of a hearing aid. So just a couple more quick points about the microphone aspect of a hearing aid. When we consider a microphone, it has a diaphragm, a membrane, not that much different in principle than the tympanic membrane, because these are sort of analogous structures, something that converts sound waves into something else. Now, the tympanic membrane, that structure at the end of your medial end of your ear canals, that structure is designed to move, to vibrate when sound waves hit it. And that vibration, that movement is actually converted into a mechanical energy of the movement of the attendant attached ossicles. In electronic terms, the microphone is a membrane, a diaphragm that moves. Sort of how it works is reasonably sophisticated in the sense that there's an electrical charge, there's an electrical field on the other side of the diaphragm, between the diaphragm and an electrically charged backplate. And when the diaphragm moves, it changes a voltage that's existing between those 2 points. And so when the diaphragm moves, that generates a voltage, and then that voltage is passed on. That changing voltage is then sent to the amplifier, where it now does something else with it. It converts it to binary code and digital cases, and if it was a straight up analog hearing aid, it would just add energy to it in a much more simpler type of processing. This slide didn't translate very well. It may be better in your slide sets, but I wanted to show you here at least sort of a cutaway of here's the back plate, here's the membrane, and as the membrane moves, the diaphragm moves, it changes this electrical field, and then there's an electrical signal that kind of comes out and goes to then wherever it's going to be sent to. So if you're a singer or you do your karaoke, many of you do maybe on the weekends. This is what the microphones sort of look like when you think of a microphone. In hearing aids, though, they look a little different. They're these little rectangular boxes. Most all hearing aids, by the way, regardless of the manufacturer of the hearing aid, most all hearing aids have microphones that are built by one company, Knowles Electronics. Knowles Electronics is a worldwide producer of hearing aid microphones and hearing aid receivers, so that those two particular component parts, regardless of what hearing aid you have, most likely you've got a Knowles microphone or a Knowles receiver in there. The receivers and the microphones don't look all that different, by the way, as you look at them. And these are just different size microphones that might be in different hearing aids. The amplifier, again, as I mentioned to you, is also, in more contemporary terms, is really a processor. It has the functional responsibility to increase the amplitude of the input signal. The amount of energy that's selectively added to all of the different frequencies we generally refer to in electronic terms as gain. So gain is an electrical engineering kind of term. And as I showed you on that other slide, output minus input equals gain. So if we said that I measured the output of a hearing aid and it was 90, and we knew that we had a 60 dB input signal, then the resulting value is 30 dB, and we could say then that we had 30 dB of gain. And so in that case, at that particular frequency, modern hearing aids modern sales of hearing aids, contemporary sales of hearing aids, require that these sorts of measurements, gain measurements, and other electroacoustic measurements of hearing aid performance be completed at various stages in both manufacturing and in the sale of hearing aids. Amplifiers, again, as I said, in contemporary amplification systems have a digital amplifier So these are undergoing, all hearing aids therefore utilize digital processing. So at some point there's a analog signal coming into the processor. That's got to get converted to digital. The processor then does whatever it does to achieve the ultimate target signal, which then it gets converted back to analog from digital, and then it's sent out to the person to hear. When we think about digital processing amplifiers, these have several features available that this slide and the next I'll just elaborate on a little bit. One of which is programmability. What this means is that this allows the audiologist or the hearing aid fitter to set the electroacoustic properties of the hearing aid. There's some elaboration in your text that talks about this specific point. But what this means is that this allows us as fitters of hearing aids to be very prescriptive. I can make a hearing aid do basically whatever I want it to do. The question is, do we know what the optimal electroacoustic parameters always are for a given individual? And the answer to that is probably not. We have some general guidelines and sort of general, conventional ways that we program hearing aids, but it would be a true statement to say that the capacity to have a hearing aid perform exactly as I would like it to has never been better. And again, I would generally call that programmability. That is to say, I can set a hearing aid to perform however I'd like it to. Another feature of digital processor is that the signal that I'm programming, the frequency spectrum that I'm working on, I can chop it up into multiple channels. It's not infinitesimal in terms of our capacity. Maybe at some point it will be, but at this point it does allow us to chop up the frequencies, the frequency spectrum of the input signal into multiple bands, and that allows us then to provide frequency-specific amplification, and so that I can provide more, much more specific amplification for some frequencies as opposed to others. And that's an important feature. That really is kind of a terrific advance provided by the digital processors. In addition, hearing aids have a better capacity now. Digital processors have a better capacity to provide what's called noise reduction. The overall intent here is to amplify speech but not background noise. And as you probably remember from your Basic Facts in Hearing Loss video series, you remember that the number one complaint of persons with hearing loss is the inability to understand speech, particularly in a background of noise. Well, in a situation in which the background noise or given a situation in which the person is listening to speech wearing their hearing aids, the problem with a hearing aid is that it's amplifying everything in the environment, including whatever background noise it may be. Now, when the background noise is not speech, hearing aids can do a reasonable job at preserving the speech energy, but not amplifying the background noise if it's not speech. Now, that's a key distinction, because if the background noise itself is speech, the hearing aid doesn't know what speech to amplify and what speech not to amplify. And that's the critical problem that faces hearing aid amplification to this day, which is how can you amplify speech but not amplified speech when it's in the background as noise. So in other words, if I'm standing there talking in a room, if I'm in a room full of people, I'm talking to just one of you, but the rest of you are talking amongst yourselves in that same room, the hearing aid doesn't know who in the room I want to listen to. Now, if I'm closer to one particular person, then certainly I'm going to get a stronger acoustic signal at the hearing aid microphone simply as a function of the distance. However, the hearing aid is going to pick up everything else. Again, if it's not speech, there's much better engineering characteristics. I'll give you the best example. I'm sure every one of you, almost on a daily basis, listen to radio in your cars, and you're listening to traffic reports. And most of these traffic reporters are coming from helicopters and airplanes, which are sitting in very, very noisy environments. Yet, we can hear their speech and understand it because the microphone that they're talking into, that speech processing sort of circuit that their speech is going into, mathematically knows what the steady state frequencies of that engine is, which is just right next to them, and excludes that from the amplification, excludes that from the circuit. So that if the energy is mathematically predictable and stable and known, we can eliminate non-speech types of noises, engines. And this is a primary focus of air-to-ground communication, other kinds of military applications like from tank to tank or from command to tank kinds of stuff in various kinds of military applications. And so again, you can tell that the sound quality is a little bit different, but it's 100% intelligible, or mostly intelligible. But again, this is a critical problem, is when the background noise is itself speech. Other features of digital processors that are useful, and again, you'll have some readings that kind of support this as well. Something called acoustic feedback cancellation. In many hearing aids, and again in older, years ago, you'd hear sort of a whistling kind of sound that would be caused by a person listening at high amplification levels. With digital processors is a much better way with what's called a variety of different names, but digital feedback suppression operates a couple of different ways, but in a sense, the hearing aid is monitoring the signal that's going out of it, and then selects it and finds analyzes it, determines what frequency it is, and adds an antiphasic frequency to it that then cancels it. So there's a possibility of cancellation, so that signal's not there anymore. Other characteristics of digital amplifiers would include the capacity to have multiple memories, multiple programs of performance. And essentially, think of this as settings for different listening situations. What did we say initially was the primary focus of what a hearing aid is supposed to do, is amplify speech. However, there may be some other situations that a person would want to listen with their hearing aid. It might be, for example, speech and quiet versus speech and noise. It might be listening to music. It might be listening to which a person might want things at a much higher amplitude, and so on. So it gives them the capacity to have different sound quality settings, more or less, as a function of different situations. And finally, something that's not necessarily something that's revolutionary in digital processors, but something that's done and executed much better, is something what's called compression circuitry. Compression circuitry is the ability of the hearing aid to control the output. And remember, I said to you a few slides back that what we need to do is to provide enough energy to make sound audible, but yet not so much to make it uncomfortable. Well, we have to be able to control output so that the output of the amplification device, again primarily hearing aid, doesn't exceed the person's level of uncomfortable loudness. And the way that we have to do that is automatically would be the best way to do it. So the hearing aid monitors its output, and if ever there's a point at which the input plus its gain equals too much output, then the hearing aid basically automatically reduces its gain, so that this then reduces the output and then keeps it comfortable. This has been a feature of hearing aids for a long time, but as I said, it's the capacity to do it is much better and much faster and much more frequency specific than it had ever been. So this is a much better characteristic than it's ever been. One last comment here before we jump out of this slide set is just kind of just filling in with the little pictures of the receivers. And again, remember the receiver in the hearing aid is that little loudspeaker. So all of these, if these look like anything from the earlier slide set, they look just like microphones. And again, most receivers in hearing aids worldwide, regardless of the manufacturer of the hearing aid, is going to be a Knowles electronics receiver. And again, regardless of whether this is acoustic, whether it's rather a digital processor, there's always going to be a need, for an air conduction type of hearing aid to convert that signal back to acoustic energy, and that is the function of the receiver in a hearing aid. So let's stop there and move on to the next slide set.